Learning objectives. First, exercise the learning from Polya's 4-step problem-solving strategy to solve the problem. Second, apply different problem strategy and solving patterns and recreational activities. Third, to become a better problem solver. Mathematics has always been viewed as a tool for problem solving. It is an integral part of providing practical solutions to many industrial problems. That is why at an early stage, math students are taught to solve different problems so that they will be able to see that they can apply their mathematical abilities to find the solution to problems. Unfortunately, some students hate math because of their difficulties in the subject. But if we approach a problem from different perspectives, we can solve it more effectively and interestingly. A new technique might help you to find answer more quickly and efficiently. It may also show an intriguing solution to the situation.
George Polya is the father of the modern emphasis mathematics education on problem solving. Dr. Polya made seminal contribution to probability, combinatorial theory, and conflict analysis. It stated that good problem solvers tend to forget the details and tend to focus on the structure of the problem, while poor problem solvers focus on the opposite. Polyas created his famous 4 steps process for problem solving, which is used for all over to aid people in problem solving. To introduce these 4 famous steps of Polyas problem solving. Step 1. Understand the problem. Step 2. Devise a plan or translate. Step 3. Carry out the plan or solve. Step 4. Look back, check, and interpret. Now, I will discuss to you Polya's 4 steps problem solving. Example, we have a problem here. Mr. Jones has a total of 25 chickens and cows on his farm. How many of each does he have if altogether there are 76 feeds? To solve and find the numbers of chickens and cows, we will use and apply the 4 Polya's process and problem solving. Step 1. Understand the problem. First, identify the given. The given is 25 animals based on the problem given and 76 feet altogether. Then the required is to find the total numbers of each chicken and cows. Now let's go to the step 2. We have to devise a plan. Let's assign different variables for unknown values. So let x be the number of cows and y be the number of chickens. If we make mathematical equations based on the given, the number of cows and chickens is equal to 25. And then, here in the second equation, y is 4x. Because here in the second equation, our concern here is the total number of each cows and chickens. So x is the cows, and we know that the cows has 4 legs or feet. It goes like this. 4x. If what is the total number of your cows times 4, then add. Then 2y or times 2, the total number of chickens, and add the result to get the total number of feet. Therefore, we have 2 mathematical equations. X plus y equals 25. Then 4x plus 2y equals 76. Now let's proceed to step 3. Carry out the plan. First, let's perform the operations based on the 2 equations, which is x plus y equals 25 and 4x plus 2y equals 76. Any of that equation you want to substitute. X plus y equals 25. Now, transpose the y so it becomes x equals 25 minus y. Then substitute by using the equation 2. 4x plus 2y equals 76. Now let's simplify the value of x. For the value of x, 25 minus y plus 2y equals 76. Now, we are done simplifying. So, we multiply 4 times 25 equals to 100. Then, 4 times y equals to negative 4y plus 2y, 76. All we need to do is to combine all like terms. So, negative 4y plus 2y equals 76 minus 100. Then add negative 4y plus 2y equals negative 2y. 76 minus 100 is equal to negative 24. Divide both sides by negative 2. Negative 2y divided by negative 2 cancel. Then equals to y. Negative 24 divided by negative 2 Cancel the negative sign, then the answer is positive 12. Therefore, the answer is positive 12 and the value of y is positive 12. So what is the value of x? Let's substitute the value of y to find the value of x. Therefore, we have x equals 25 minus y. Bring down 25. The value of y is 12. 25 minus 12, the answer is 13. Therefore, the value of x is positive 13. Now, let's proceed to the last and final step. The step 4, look back. It means we need to check, we need to verify the answer if it is valid or not. Our first equation is 25. So, x equals 13 plus y equals 12. Then add 13 plus 12 equals 25. So, therefore, the answer is 25. We get the correct answer in our first equation. When it comes to the second equation, let's do the same thing. 4x plus 2y equals 76. Substitute the variables. 4, the values of x, 13, times 2, the values of y, 12, equals 76. 4 times 13 equals 52. 2 times 12 equals 24. Then add the result. 52 plus 24 equals 76. Therefore, the answer is correct. I hope that you learned our lesson.
Mathematical problems involving patterns. So pattern include a series or sequence that generally repeats itself. The patterns that we observe in our daily life are those of colors, numbers, shapes, or actions. So they can be related to any event or object and can be infinite or infinite. So in mathematics, patterns are a set of numbers arranged in a sequence such that they are related to each other in a specific rule. So the rule defines a way to calculate or to solve problems. For example, in a sequence 3, 6, 9, and 12. So each number is increasing by 3. So according to the pattern, the last number will be 12 plus 3 equals 15. So we have different types of pattern and sequence that can be formed with number. We have arithmetic sequence, geometric sequence, Fibonacci sequence, harmonic sequence, triangular number sequence, square number sequence, and lastly we have the cube number sequence. So we have also types of patterns. So we have repeating pattern. It is a pattern that keeps repeating over and over again in the sequence of number is called the repeating pattern. So we have also growing pattern. So it is numbers or objects are arranged in an increasing order in a sequence. That pattern is a growing pattern. So lastly, we have a shrinking pattern. It is a pattern where numbers or objects are arranged in a decreasing order. So here are the examples of different types of pattern.
An example of recreational activity is Sudoku. This simple but endlessly fascinating game gives students the satisfaction of using logic to solve a puzzle. Card games like Tongits and many more is also an example of mathematical problem solving. It is a game where both player analyzes on how to win the game. Recreational problem solving is fun and I would recommend this activity for everyone. Solve, win, and have fun. Sasaya ka na, tatalino ka pa.
Good day each and everybody, I'm Jamaica Pamela Ruben and for today's video, I'm going to sum up the 3 topics which are Polya's 4-step in problem solving, mathematical problems involving patterns, and recreational problem using mathematics. In this topic, we look at Polya's 4 steps in problem solving process, which is systematic approach to finding a solution to a problem. First, understand the problem. Restating the problem and identifying necessary information is a key to this step. Second, devise a plan. Use equations, diagrams, table, or any other tool needed to create a plan for solving the problem. Third, carry out the plan, solve the equation you've created following analytical rules and techniques until you reach the conclusion. Fourth, look back. This means to review your work to double-check your answer. Next up, the mathematical problems involving patterns. These patterns can be used to help you determine the proper and realistic value. Pattern aids us in solving difficulties quickly and confirms our responses right away in a variety of ways. And in recreational problems, using mathematical are short intellectual tasks that are frequently connected with puzzles. They may or may not require mathematical solutions, but they almost always require critical thinking and creative tactics.
Good day everyone, my name is Robijin Ibado and this is our conclusion in our topic. Problem solving reasoning is a thesis section under logical reasoning which involves solving problems by performing various mathematical operations. Important topics that come under problem solving reasoning are inequality, analogy, series, puzzle, and so on. Therefore, problem solving in learning mathematics comes from the belief that mathematics is primarily about reasoning, not memorizing. Problem solving allows students to develop understanding and explain the processes used to arrive the solutions rather than remembering and applying a set of procedures.